From the beautiful North Studios of Way Happy, this is Mr. Meyer and P2 linear models and what more important rates of change. This is going to feel very, very familiar because you can see from the objectives that you're reading, we see that we have to do the slope of a line. We have to write the equation of a line given a point and a slope. These are things you've been doing for a long time now, and so they feel very comfortable and very normal. In fact, we do a lot in this beginning. This whole thing leads to derivatives. And so derivatives is a very tricky calculus concept of finding the slope of a curve rather than the slope of a line. So you got to make sure you know how to do the slope of a line because we're going to use that logic in order to find the slope of a curve. Right? One of these twisty graphs, we need to find their slope. And really what it's going to be is the rate that it's changing at, how the rate of if it represents something flying, maybe it's velocity or its speed. So that's all going to be stuff that we will calculate. So there you go. Definition of a slope is the change in the y value over the change in the x value right there. Right? Delta means change. And how did you find that change? You subtracted the y's and you subtracted the x's. So rise over run was always the change in the y values over the change in the x values. And that's all it ever was. So you can see I have a couple examples right below that where I say we have a positive slope and you can see the slope was 1/5. I have a zero slope where you can see it leveled off and it's left the same slope where it was. You can see a negative slope. And so all these different slopes are found, or even that last one where I have an undefined slope. So be careful. All these slopes are possible when you are doing these fun-filled problems. All right. So how do you find the equation of a line? So if I'm going to find the equation of a line, probably the most common way I'm going to use in calculus is I'm going to use slope point, right? So the point slope formula, where if you give me a point and you give me the slope, I can find the equation thanks to this right here. And I can quickly turn that into slope intercept, as you'll see in a little bit. But let's go ahead and try this. They know we got a slope of 3 and they know we want to go through this point. Then can you tell me the equation of that line? Well, of course. I'll just go y minus y1 equals mx minus x1. And I will plug in my point, which we say was 1, -2. And I will plug in my slope, which is 3. And there it is. There's your equation of your line. And then happy-go-lucky, done. That is called point slope form. It is that easy. You can distribute the 3. You can clean it up. You can move the 2 to the other side so it looks like slope intercept. Or you could just give me the equation because we're going to put it in a graphing calculator or whatever. How would I graph this? I don't know. I'd either use that equation or I would plot the point 1, -2. And then I would do a slope of 3, which is up 1, 2, 3 over 1. And I would graph my line like this and say, there's your equation of your line. So that is how we will that's how we will graph. And that is point slope form of an equation. Now, the slope, right, is either a ratio or a rate. Now, what's the difference there? If there's no units, we call it a ratio. And if there is units, we call it a rate because that's how quickly the rate of change is going. So if you look at example 2 here, it says that the recommended slope is 1/12. That right there with no units, that is telling me that this is a ratio. So the units are the same. They're either inches or feet or whatever. So it's always that ratio of 1 inch up to 12 inches across. A business installs a wheelchair ramp that rises 22 inches over 24 feet. Is that steeper than recommended? So now if I want to compare this, well, you can see I have 2 different conversions. So I could call this, it rises 22 inches over 24 feet. Now you can see that that is definitely what we would call a rate. So this because it has different units. Or I could convert it into one simple unit. Maybe I'm going to change the 24 feet into inches. I don't know what 24 times 12 is. Well, I know 24 times 10 is 240. 24 times 2 is 48. So I think that's 288. So that's 22 over 288. That is in inches. Right? So there is a nice ratio. Now that ratio can be reduced. Let's see, they both are divisible by 2, so it's 11 over 144. And I can figure out what that is in decimal, and I can figure out what the 1/12 is in decimal. And once I do that, I would be able to tell you if it's too steep or steep enough. So if I do 1 divided by 12 in decimal, 1/12 is 0.083. And what we have is 11 1/44 is approximately equal to 0.7638. You can see that ours, this one is definitely smaller than the recommended. And so therefore we're good to go. Oh, I forgot a zero. Sorry, 0.07. That would make more sense. All right, so there you go. That is a beautiful, beautiful example of a problem there. Let's try example 3. The population of Colorado was this much in 2000 and this much in 2010. Find the average rate of change of the population over this 10-year period. So how would I find the average rate? Well, I would do the change in population over the change in years. That's what I would do for this problem. So the population went from 5029000 4302000. So that's the population change. Over the years, we went from 2010 to 2000. And you can see that, let me grab a calculator real quick. I can type in, I have to put a Sheila on this thing. I have 5029000. I guess I didn't really need those. Minus 4302000 is 727,000 people in 10 years, or lop that off, right? And you can see 72,700 people per year. So this is population, right? This is people right here. And this is 1 year, or what we would just call is people per year, 72,000 per year. So now if they were to continue that, how would I figure out what the population was going to be in 2020? Well, I'd be like, that's 10 years later. So I'm going to multiply that back by 10 or get 727,000 again and add that to the 5,000 mark. So let's see, add, what did I do? Add that to 5029000. And I am predicting that in 2020, they will have 5,756 or 5,756,000 people in Colorado. There you go. Let me ask you a question and I'll be right back. All right, nice work. Now, let's talk about graphing linear models. This, we can talk about here is we're just going to talk about the different ways you can write an equation. You can read a bunch of the stuff that I typed up here, but you should be able to find equations of lines pretty easily. There's another way to do it, the one you're probably more familiar with, that's called slope-intercept form. And there it is, y equals mx plus b. You have to know the slope and the intercept. Then the next part I mentioned there is that I say, if you have a vertical line, you can't write it in slope intercept form. And that's why we have this thing called general form. This is general form right here. Every equation can also be written in that form. Now, am I going to ask you about all these different forms all the time? Not really. I just want you to know the vocab, know that there is point slope form, know that there is slope intercept form, know that there is general form. I put it all in that little summary box right here, right? So here's a nice little summary box for you to know the different types of equations and different equations that we would use. Good? All right, what's more important right here? Parallel and perpendicular lines. Do you remember that rule? If not, let's brush off a little dust here. If you are parallel lines, then your slopes are the same. Your y-intercepts are different, right? You have one y-intercept here and the other one's going to be down here. The y-intercepts are different, but the slopes are definitely the same. So that looks very familiar. When your slope values are the same, check your y-intercept, make sure it's not the same line. But if it's not, then you have what we call parallel lines. The other one is perpendicular lines. And what they are is after you have one slope, the other slope would be the opposite reciprocal. What does opposite mean? It means change the sign. Reciprocal means flip that number, right? So an opposite reciprocal slope would give you what is called a perpendicular line. So that, very important to know too, because sometimes we're going to need to decide if things are parallel or perpendicular or neither. And that's how you would check. So down here, you can see I have find the general forms of the equation of the lines that pass through that point, and I want one to be perpendicular and one to be parallel. So the trick here is I have a point, I just need a slope, right? And so how do I find a slope? Well, I'm going to take this equation that we have right here, and I'm going to find its slope. So I'll probably move the 2x minus 5. I moved the 5 over, which means I had to move the 3y over. And what is it doing? 3y. And then I divide everybody by y, I would get something crazy. It doesn't like where I am. Y equals 2/3 x minus 5/3. But all I really cared about was that right there, the 2/3. So if you want a parallel line, it's going to be y minus y1 equals parallel, same slope, x minus 2. And if you want the perpendicular line, here, I'll do it in a different color. If you want the perpendicular line, it's y. All right, we're having, as you can see, some difficulties here. Y plus 1 equals, now take that slope, make it opposite, and flip it, and use that same point, and there you go. That would be the opposite reciprocal slope. So I figured out the slope, and once I knew the slope and the point, I was able to give you two equations, and there they are. There's parallel, there's perpendicular. We're good. Have a great day. Stay happy, and I'll see you tomorrow.